For this question, we're given the volume of a spherical bubble increases at a constant rate of 5 centimeters cubed per second. We can assume its initial volume is 0, and we need to find the rate in centimeters per second at which the radius is increasing when the volume of the bubble is 20 centimeters cubed. So with these rates of change questions, we can just apply the chain rule. So since the volume depends on the radius and the radius depends on time, we just apply the chain rule. So let's look at how we do this. So how the volume changes with respect to time, well, that is going to equal how the volume changes with respect to the radius multiplied by the rate of change of the radius with respect to time. So that is dr by dt. Okay, and this is the one we want to find. dv dt we know is 5 centimeters cubed per second. And dv dr we can work out. So let's write down all the information that we know. So we know dv dt is equal to 5. Now the volume, so the volume of a sphere is 4/3 pi r cubed. So therefore the volume with respect to the radius is just going to be 4 pi r squared. Okay, so now we've got this. So we've got 5 is equal to 4 pi r squared times dr by dt. So now we just need to know r for this equation. So we're looking to find the rate at which the radius is increasing when the volume of the bubble is 20 centimeters cubed. So if the volume is 20, well, that's going to equal 4/3 pi r cubed. And now we just have to solve that for r. So we're going to get 60 equal to 4 pi r cubed. Divide both sides by 4. So 60 over 4 is just 15. And therefore r cubed is 15 over pi. So this implies then that r is 15 over pi to the power of 1/3. So we'll write that down as a decimal. So we'll get the calculator up. Okay, so we've got it typed in here. So r is about 1.68389. That 1.68389. You can leave it just as that 15 over pi all to the power of 1/3, but writing it as a number here, 1.6389, so on, just might make it a bit easier to put onto the calculator later. Okay, so now we can go about solving for dr by dt. So we'll write down what we've got then. So we know then that 5 over 4 pi r squared, I'll just leave it with the r squared like that for now, is equal to dr by dt. And that then is going to be 4 times pi, and we found r to be that 1.68389 and so on squared, and that will equal dr dt. And we'll just go about putting that into the calculator. Okay, so we've got it typed in there and put it in. We get about 0.14324. That is equal to 0.140324 and so on. So to three significant figures, dr by dt is 0.140.